Welcome to the third and final section of Binance Academy's Blockchain Deep Dive Intermediate course. In this section, we'll explore the revolutionary shift from centralized Web 2.0 to decentralized Web 3 and how blockchain technology is reshaping data ownership, privacy, business models, and use cases across 3 modules. In this module, we'll delve into data ownership in the context of blockchain technology and Web 3. We'll learn more about self-sovereign identities, decentralized data storage, data privacy, and how data ownership is being redefined in the digital age. Before we start, let's recap Web 3, a concept we learned in Binance Academy's beginner course on Web 3 and the metaverse. Web 3 represents the next generation of the Internet, which envisions a decentralized online ecosystem powered by blockchain technology. Web 3 aims to return data ownership and control to individual users, enabling peer-to-peer interactions without intermediaries, and fosters a more transparent, secure, and privacy-focused digital environment. Data is the lifeblood of the digital age. But since the emergence of the Internet during the late 1990s, digital ecosystems have become increasingly centralized, with big technology platforms generally serving as the aggregator, profit-taker, and arbiter of user data. The giant tech platforms of social media, online shopping, and online search are examples of this business model. The emerging technologies of blockchain and Web 3 aim to disrupt this status quo, offering a new digital world where individuals regain control over their personal data. Blockchain technology is instrumental in enabling this shift. Blockchain's inherent decentralization eliminates a single point of control, while its transparency gives data access to every user, not just the centralized intermediaries. Blockchain-based social networks where users host their own servers and have full control over their data is just one example of these concepts being brought to life. Users can receive rewards for publishing and curating content, removing the need for centralized platforms and advertisers. Users are not stuck with any particular social media platform and can easily migrate their data to other networks whenever they want. They can also decide what personal data to share and with whom. An important concept in this shift is self-sovereign identity, which refers to the idea that individuals should have sole ownership of their digital identities and control over how their personal data is shared and used. In other words, a person should have the same sovereignty, autonomy, control, and freedom over their digital identity as they do over their physical one. There are many experimental applications allowing users to achieve self-sovereign identity. For instance, some are built on the Ethereum blockchain, letting users register their own identity, sign transactions, send and request credentials, and prove their identity to governments to access citizen services. Blockchain can also contribute to data privacy. On the blockchain, users are generally identified by addresses that serve as their public keys. Addresses are usually not linked to individuals' real-world identities, which provides a level of pseudonymity. However, blockchain records all transactions on a public ledger, which means anyone can see which transactions are linked to which address. Therefore, blockchain provides a level of pseudonymity but not complete anonymity. It's essential to differentiate the two often misunderstood concepts. Another critical component of Web 3 is decentralized data storage, an approach to storing data across multiple nodes rather than in a single centralized location or repository, such as a traditional data center. It addresses some of the major issues relating to privacy, data ownership, and control prevalent in Web 2 organizations. For instance, centralized data storage can be a prime target for hackers, leading to large-scale data breaches and sensitive user data stolen. They also face criticism for opaque data practices and privacy infringement. Decentralized data storage provides the infrastructure needed to store and access data in a way that's both secure and doesn't rely on centralized entities. An example of decentralized data storage service that's currently on the market is one that lets anyone rent out their unused digital storage space to store files on a decentralized cloud storage platform. Each file is encrypted, split into pieces, and distributed on a large network to ensure no single point of failure. The transition to self-sovereign data ownership in the Web3 era uncovers exciting new possibilities. Consider a fitness app where users log their workouts and dietary habits. In a Web3 context, the data belongs to the users, not the app developers. Users can selectively share data with their doctor, a nutritionist, or even monetize it by selling it to a research institution. However, this new paradigm also brings challenges. There are significant legal and regulatory challenges to be addressed, including data protection laws, risks of losing one's private keys, scalability, and efficiency challenges. While blockchain is secure, it isn't impervious to attacks. Ensuring the security of user data in a decentralized context is a complex challenge that goes beyond robust technology. In the next module, we'll explore how this shift in data ownership in Web3 could enable users to partake in the value generated by their data, and what kind of new business models and tokenomics could be generated.